Hi guys, for today we're going to find the derivative of natural logarithms. Okay, so let's start with the most basic idea. So we have here y is equal to ln of x. So if we have the function of y is equal to ln of x, your derivative will just be 1 over x. And that's just it. Easy, right? So let's take a look at some examples that we're going to use, or we're going to find the derivatives of natural logarithms. So let's take a look at first example number 1. So we have here y is equal to the ln of 3x squared plus 2x. Now, if you notice, we have here an inner function of 3x squared plus 2x and an outer function of ln of 3x squared plus 2x. So therefore, we're going to use the chain rule. So in order for us to get this derivative, we need to find the chain rule. So what's the chain rule again? The chain rule states that inner derivative, which is your 3x squared plus 2x, okay, multiplied by the outer derivative of the other function. So we are now just going to have a derivative, therefore, of the derivative of our inner function. That will just give us 6x plus 2, right? Okay. Multiplied by the inverse of our outer function. So you will have 1 over 3x squared plus 2x. So let us now try to simplify this. We're just going to have y prime. This is therefore equal to 6x plus 2 over 3x squared plus 2x. Easy, right? Okay, let's take a look at now example number 2. So for example number 2, we're going to involve some trigonometric ratios. So what happens if we therefore have y is equal to the ln of sine x? So again, inner derivative multiplied by the outer derivative. Our inner function is sine x. Our outside function is ln of sine x. So we now have y prime, which is therefore equal to the derivative of sine x. That will just give us cosine x. The derivative of ln of sine x, that will just give us 1 over sine x. So we now therefore have y prime is equal to cosine x over sine x, or y prime will just be equal to cotangent of x, because cosine over sine is just equal to cotangent of x. Easy, right? So let's take a look at example number 3. So we're going back to our polynomials. We now have y is equal to the ln of 2x cubed plus 4 over 3x. So it's the ln of 2x cubed plus 4 over 3x. So again, guys, we're still going to have an inner function multiplied by the outer function, or should I say, my bad, should I say, so guys, we're now going to have y is equal to ln of 2x cubed plus 4 over 3x. So we still have an inner function and an outer function. So therefore, we're going to use our chain rule. And not only that, we also have to use your quotient rule. QUO. I just wanted to know that that's the correct spelling. I think it's, yes, that's the correct spelling. So the quotient rule and the chain rule. Okay, so let's begin. So let's try first to have a little review of what the quotient rule is. So if I think you guys would still remember low d high minus high d low all over the square of low. Or I could just like maybe erase my x so that you guys won't be able to get confused. So low d high, what does low d high mean? Low, that's your denominator, multiplied by the derivative of your numerator, low d high, minus high, that's 2x cubed plus 4, multiplied by the derivative of our low, okay, the 3x, all over the square of our denominator. So you have low d high minus high d low over low squared. Again, guys, that's just for our quotient rule. So let's get to work. So we now have y prime is just therefore equal to low, that's our 3x, okay, multiply that by the derivative of our high, which is just equal to 6x squared, okay, minus high, which is again just equal to 2x cubed plus 4 multiplied by the derivative of our denominator, which is just 3, all over the square of 3x. So in this case, I'll just do 3x quantity squared. We can write down 9x squared, but I think this will be a lot more easier for me. And I think you will get the idea later on, pretty soon. So guys, again, this is our inner derivative, and we still need to multiply that by the 1 over x, or the reciprocal of our 2x cubed plus 4 over 3x. So that will just give us 3x over 2x cubed plus 4. Okay, notice, okay, let's try to simplify it a little bit more. So you'll have y prime will now give us 3x times 6x squared. That will just give us 18x cubed minus, notice guys, I'm still going to use the parenthesis because it is being preceded by a negative sign. So I'll just distribute first my 3 to my 2x cubed plus 4. So we now have 6x cubed plus 12 over, okay, we have a 3x squared, 3x quantity squared at the bottom, and we also have 3x on top. So what we could do is just cancel our 3x, okay, and this 2, the exponent of 2 will now become a 1. So we now have at the bottom of 3x multiplied by 2x cubed plus 4. We could still further simplify this as 18x cubed minus 6x cubed minus 12 over 3x multiplied to 2x cubed plus 4. Okay, I think we could combine like terms at our numerator. So this one will now just give us, hopefully I have enough space right here. We can now just have y prime is equal to 18x cubed minus 6x cubed. That will just give us 12x cubed minus 12 over, okay, notice guys, I got 2 and I got 4. I could factor out my 2. So that will now give me 3x multiplied to 2, okay, multiplied to x cubed plus 2. But there's a specific reason why I wanted to factor out my 2, which you will see in just a moment. So guys, that's 12x cubed minus 12x. Naturally, the common factor is 12, so we factor out our 12. This will just give us x cubed minus 1, right? All over, okay? 3x times 2, that will just give us 6x multiplied to x cubed plus 2. What can we cancel out? We could cancel out your 12 and 6, that will just give us a 2. So therefore, your final answer will just give us 2 multiplied to x cubed minus 1 all over x multiplied to x cubed plus 2. If you want to distribute your x, that'd be fine, but you can also have this as your final answer. So I hope guys those 3 examples will give you a better understanding on how to get the derivative of natural logarithms. If you like the video, I would highly appreciate if you'd press like and subscribe. Thank you so much and see you next time.